Hi everyone and welcome to Smart Alex Coaching. We offer mathematics tutoring for primary and high school students, both online and face-to-face. This is part 2 of a series of videos on the trigonometric functions, and in this video we're going to be looking at the related acute angle. In part 1, we learned that sine, cos, and tan can be defined using the unit circle. One of the advantages was that instead of theta being restricted to being between 0 and 90 degrees, we can now work with obtuse angles, angles greater than 360 degrees, and even negative angles. But what I want to show you is regardless of what angle theta is and what quadrant it's in, we can always relate it back to the acute angle in quadrant 1. Firstly, suppose I've got a point P with coordinate xy in quadrant 1. So here's my point P with coordinate xy. And what I'm going to do is I'm going to construct a right angle triangle. Here's going to be my right angle. That's going to be x and that's going to be y. This is angle theta. And what I'm going to do is I'm going to construct an identical triangle in quadrant 2. And I'm going to give this point here, I'm going to call it P dash, and it's going to have the coordinate minus x, y. So here's my right angle triangle. That's minus x, and that's going to be y. This angle is theta also. And just note here that at P dash, this is going to correspond to the angle 180 degrees minus theta. Recall from convention, we start from the positive x-axis at 0 degrees and we move anti-clockwise for a positive angle. These two triangles, I can prove that they are congruent using the AAS test, which states that two angles are the same. I've got my theta that are the same and my right angles that are the same. And these two sides are the same, being the radius of the unit circle. In quadrant 1 at P, I've got sine theta is equal to y, cos theta is equal to x, and tan theta is equal to y on x. In quadrant 2, at P dash, I'm going to have sine 180 degrees minus theta is equal to y, which is equal to sine theta. Cos 180 degrees minus theta is going to be equal to minus x, which is the same as minus cos theta, and tan 180 degrees minus theta, which is minus y on x, will be the same as minus tan theta. So what I've got here is the relationship between sine, cos, and tan of an obtuse angle with sine, cos, and tan of an acute angle. I can do the same in quadrant 1 and quadrant 3. Again, in quadrant 1, I've got the point P, xy. Here's my right angle triangle. That's theta. This is x, and this is y. In quadrant 3, I'm also going to construct an identical triangle. And this is going to be the point P dash. It's going to have the coordinate minus x minus y. That's minus x. And that's minus y. Here's theta. And at P dash, this corresponds to the angle 180 degrees plus theta. At P, again, sine theta is equal to y, cos theta is equal to x, tan theta is equal to y on x. At P dash, what I've got is sine 180 degrees plus theta is equal to minus y, which is minus sine theta. Cos 180 degrees plus theta is equal to minus x, which is minus cos theta, and tan 180 degrees plus theta is equal to minus y over minus x, which is tan theta. Again, I'm able to relate the sine, cos, and tan of the angle in the third quadrant to the acute angle in the first quadrant. Repeating the same process for quadrant 4 as well. Here's my point P with coordinate x, y. Here's my right angle triangle. That's my theta. That's my right angle. That's x. And this is y. Constructing an identical triangle in quadrant 4. This is P dash. It's going to have the coordinate x minus y. So minus y is going to be here. That's theta. At P, sine theta is equal to y, cos theta is equal to x, and tan theta is equal to y on x. At P dash now, I've got sine, and the angle is going to be 360 degrees minus theta, because 360 degrees is like resetting the whole thing back to our starting point. Then with minus theta, which is a movement in the clockwise direction. So we've got sine 360 degrees minus theta is going to be the same as minus y, which is minus sine theta. Cos 360 degrees minus theta is going to be x, which is just cos theta, and tan 360 degrees minus theta will be minus y on x, which is minus tan theta. So what we've got is we've got the connection between all the sine, cos, and tan of angles in any quadrant to the sine, cos, and tan of the acute angle in quadrant 1. And the table here summarizes those relationships. Let's look at an example. I want to evaluate cos 225 degrees. Well, cos 225 degrees can be written as cos 180 degrees plus 45 degrees. I'm going to use the relationship of cos 180 degrees plus theta is equal to minus cos theta, and this will be the same as minus cos 45 degree, which is just minus 1 over root 2. In this second example, I'm not given a specific angle, I'm given an identity. Cos 180 degrees minus A can reduce to just minus cos A. Sec A is the same as 1 over cos A. So if I multiply those two together, the cos A cancels out, giving me a final answer of minus 1. Thank you for watching this video, and I hope that you like it. If you do like it, please share it and consider subscribing. Until then, enjoy maths, and I'll see you in the next one.